Now we are moving to the second chapter of 9th standard, polynomials. The chapter name is polynomials. And before knowing polynomials, just we recall expressions, what we have studied in the previous classes. So expressions. So what is an expression? An expression is the combination of arithmetic operations, variables and numerals. So this is called expression. For example, you see here x plus 3. So x plus 3, there you can have x as a variable. We use to denote the variables only the alphabets. So in x plus 3, x is the variable and plus 3 is the numeral. It's a constant. Another example, y minus 3. So y is the variable here and minus 3 is the numeral. And in x square plus x minus 1, x square is one term, x is another term and minus 1 is another term. So here 3 terms. So it is expression, example of expression. Another way, we can say 1 by x minus 5 is also an example for expression. So now, what is the difference between these two examples means? Here x, the power or exponent of this variable x is 1. But here 1 by x means that is x power minus 1. So it is the negative power will come if you bring it to the numerator. So if it is 1 by x, so it is 1 by x minus 5, 1 by x is one term and minus 5 is another term. So this is also example of expression. And here you see minus 1 by y and then minus 7. So it is a kind of expression. Here you see 5 by m square plus 3 by m minus 1 by 2. So these are the examples of expressions. And in the earlier classes, I think you put various problems like sum of the expressions, subtracting expression from another expression. So these are the examples. Here, while moving into polynomial, 2x, example of polynomial, x square plus 2x is the example of polynomial, minus x square plus 4x plus 7. So is one example. So what is the difference between expression and polynomial? And here you can notice the exponent of the variable in each and every expression. So these are also expression, but we can say these are polynomials also. But what is the difference? Expression, you know the exponent of this example. Here variable is x whose exponent is 1. Here also variable is y, the exponent is 1. Here in this expression x square is there. So x square is a term and the exponent is 2. Here x is another term whose exponent is 1 and this is constant minus 1. And here you see 1 by x. So here the variable is in the denominator. So if you apply the power, that means if you want to get the power, it is in the denominator is x power 1. While bringing to numerator, the exponent becomes minus 1. So like that here also, y is in the denominator. When we bring it to the numerator, the exponent of y becomes y power minus 1. Here, m power minus 2 when you bring to the numerator. And you see m is in the denominator. And when you bring to the numerator, the exponent becomes m power minus 1. And here minus 1 by 2 is a constant. Constant not a matter. Only you have to focus on the variable. Whereas in polynomials, the exponent of every variable should be whole number. The whole number only should be the exponent of every variable. So I have taken only the x term only x variable only I have taken. So here 2x is an expression and also it is a polynomial. And x square plus 2x, this expression is also a polynomial because the exponent of x is 2 and here in 2x the exponent is 1 and here minus x square plus 4x plus 7. minus is the sign of x square, but the exponent of x is 2 only, and here the exponent of x is 1 and 7 is the constant. So we can see now what are the terms and coefficients just for recall. In x square plus 2x, x square and 2x are the terms. And coming to coefficients, just you take minus x square plus 4x plus 7. In this, coefficients of the first term minus x square is minus 1, the numeral before the variable or the term. 4x is the term whose coefficient is 4. And 7 is a constant, and you can say 7 as 7 x power 0. That means what? Anything power 0 is 1. So you can write 7 as 7 into x power 0. So only I have given a different color. 7 is the number, and you can write it as 7 into x power 0, and whose coefficient is 7, a constant. And you see expressions like x plus 1 by x, root x plus 3, x power minus 1, these are not polynomials. You know why? Because the exponent of the variable in each expression, x plus 1 by x, you see here the exponent is 1, but here you get x power minus 1. And you see here root x plus 3, root x, if you write in exponent form, root x becomes x power 1 by 2. That we have learned in the first chapter, number system. So root x means in exponent form x power 1 by 2. So here the exponent is not a whole number, and plus 3 is a constant. Here also x power minus 1. So it is, the exponent is also not a whole number. So when the exponent is not a whole number, then that expressions are not polynomials. Now I think you are clear about what is expression and polynomial. Okay, now we discussed about what is expression and what is polynomial, and now we can see some more points. X square minus x plus 2 is a polynomial, and you know how many terms are here. X square is one term, minus x is another term, 2 is another term. So it's a polynomial. And 5 is a numeral, that means numerical constant. So 5 is also a polynomial. So therefore we can say all the constants like 5, minus 2, 7 are called constant polynomial. Constant itself we can say constant polynomial. So now important point is there, the constant polynomial is 0. 0 is also a constant, but this 0 is called zero polynomial. So it plays the main role in the collection of polynomials that you see in high classes. So the constant polynomial 0 is called the zero polynomial. And in the earlier classes, I think you study about polynomials based on terms and based on degrees. We can classify it. So based on the terms, if there is only one term, we can say it is monomial. For example, minus 5x. And if it is two terms, x plus 7, there are two terms. X is one term, 7 is another term. So two terms, it is called binomial. And next one is trinomial. 2x square minus 3x plus 9 is an example where there is three terms. So it is trinomial. So more than that, all are polynomials. So monomial is a polynomial, trinomial is a polynomial. This is also polynomial. But specifically, if it is one, it is monomial. And if there is two terms, it is binomial. And there is three, it is trinomial. So more than that, we say all are polynomials. And now coming to based on degrees, you see linear polynomial, quadratic polynomial, cubic polynomial, biquadratic polynomial. So linear means there should be the degree we have to focus the degree of the variable y here in 5y. The degree of the variable y is 1 into 1. That is 5 we can write as 5y power 1. That is the degree being the highest power of the variable. Highest power of the variable. So 5y we can write as 5 into y power 1. So the exponent here is 1. The variable is y and whose exponent is 1. That is the highest power. And so here let me take as linear polynomial. If the degree of a polynomial is 1, then it is linear polynomial. And now coming to quadratic polynomial. For example, you take x square plus x plus 1. Here the variable is x. The exponent of x square is 2 and x is 1. So the highest exponent, the highest power here is 2. So the degree is 2. The highest power is the degree. So here the degree is 2. So we name it as quadratic polynomial. So in a polynomial, if the degree is 2, then it is called quadratic polynomial. Now coming to cubic polynomial, if the degree is 3, then we can say it is cubic polynomial. Now you see here, x cube minus 4x square plus x minus 3 is a polynomial. Whereas the degree, that means highest power of the variable x is 3. So here the degree is 3 and we can say it is a cubic polynomial. And if it is the degree 4, then we can say it's biquadratic. Bi means 2. Quadratic is also 2. So totally 4. So if the degree is 4, for example, you see here x power 4 and then minus 3x cube plus 2x square and the other terms are no more. But the highest power here is 4. So with that we can say it is a biquadratic polynomial. So more than that we can say the degree, whatever it is the highest power, if it is 5, the degree is 5. The highest power of the polynomial is 7, then we can say the degree is 7. So like that we can do. So that coming to the constant polynomial. 7, for example, 7. 7 is a constant polynomial. So what is the degree of the constant polynomial? So degree of a non-zero constant polynomial. Non-zero means what? Except 0. So suppose if I take 7. 7 is a non-zero constant polynomial. So what is the degree of it? We can write 7 as 7 into x power 0. So x power 0 means what? Is 1 only. So that means 7 into 1, that is 7. So I have written here 7 is equal to 7 into x power 0. Like that you can write. So x power 0, the degree here is 0. So only the degree of a non-zero constant polynomial is 0. So you can write with any variable you can write 7 y power 0. So like that with any variable you can write whose value is 1 only. 7 into 1. So it becomes only 7. So the generally we can say the degree of non-zero constant polynomial is 0. And coming to zero polynomial. Zero polynomial. That is nothing but what? 0. The number 0 is called zero polynomial. So what is the degree of zero polynomial? Degree of a zero polynomial is not defined. Why? We can write 0 as 0. We can write as 0 into x power 5 or 0 into y power 7. You see here, 0 we can write as 0 into x power 5 or 0 into y power 7 with any variable, with any exponent we can write. When you multiply with 0, you get only 0. So the degree of a zero polynomial is not defined. We cannot define it. So this is the classification of polynomials under number of terms and the degree, and then we move to the next is the exercise 2.1. And now, a polynomial in one variable x of degree n is an expression of the form p of x is equal to. P of x means polynomial in terms of x is equal to an x power n plus an minus 1 x power n minus 1 plus etc. plus a1x plus a0. So where a0, a1, a2, etc. an are constants and an not equal to 0. What is an? An is the coefficient of x power n. The condition is the coefficient of x power n non-zero, not equal to 0. So then only we can say it is a nth degree polynomial. For example, x square minus 5. So it is a second degree polynomial. If the coefficient of this x square is 0, then we cannot get x square term. So the condition is an, which is the coefficient of x power n, not equal to 0. So this is the general form of a polynomial. In exercise 2.1, the first sum, they are asking which of the following expressions are polynomials in one variable and which are not. State reasons also. For example, 4x square minus 3x plus 7. Is it polynomial or not? That is the question. So can you say? For that we have to notice the exponents of the term. Here what is the variable x, and there are three terms, 4x square, another is minus 3x, another is 7, and the variable is x. What is the exponent of the variable? Here 2, here x power 1, here it is x power 0. 7 means we can say 7 x power 0. So here all the exponents of the variable is whole number only. If it's so, then you can say it is a polynomial. It is a polynomial. Right. The reason is the exponents of the variable is whole number. Option 2, y square plus root 2. Here the variable is y, whose exponent is 2. So it is also whole number. The exponent is 2 is whole number. And here root 2. Root 2 means it's a constant. Constant may be root also. So we have to notice only the variable and the exponent of the variable. See here the exponent of the variable y is 2. So we can say it is also polynomial. So that is the reason. And here third option, 3 root 2 plus t root 2. First you notice the variable t. Here the variable is inside the radical sign root t. So root t means what? Root t means t power 1 by 2. That we know. T power 1 by 2. You can write root t in exponent form as t power 1 by 2. So the exponent 1 by 2 is not a whole number. So the condition is, the exponent of the variable of a polynomial should be whole number. So it is not like that. So it is not a polynomial. It is not a polynomial. And coming to this option, y plus 2 by y. So this variable y, the exponent is 1. But what about here? The variable is in the denominator. So 2 by y means this 2 in y power minus 1. You can write like this in exponent form. You can write 2 by y as 2 into y power minus 1. So the exponent of the variable y here is minus 1, a negative number. It is not a whole number. So it is not a polynomial. It is not a polynomial. So that is the reason. The exponent of the variable y is not a whole number. And option 5, you see the variables are different. It is not in one variable. x is there, y is there, p is there, but you see the exponent, x power 10, y power 3, and then p power 50. So it is a polynomial but not in one variable. The question is, which of the following are polynomials in one variable they are asking. Generally it is a polynomial but in different variable. But their question is polynomial in one variable they are asking. But here it is 3 variables. Even though the exponents are whole number, but the variables are more than 1. So it is not. According to the question, it is not a polynomial in one variable. So these are the solution and the way of answering. And now coming to question number 2, 4 more options are given. And the question is, write the coefficients of x square in each of the following. It is very simple. So you have to observe the term x square only. So already we have seen what is the term and what is the coefficient, everything. So now they are asking the coefficient of x square alone. So you see here 2 plus x square plus x is a polynomial, and you observe x square. So here x square coefficient is 1. If there is no numeral, we have to take that it is 1. So coefficient of x square is coefficient of x square is 1 here. And now coming to the second option, x square is here, but the sign is minus. But there is no number, it means minus x square means there is minus 1 x square. Like that we can take. So the coefficient of x square means here minus 1. Coefficient of x square is minus 1 in this question. And now coming to option 3, pi by 2 x square plus x. So here you observe pi by 2 x square. So x square and whose coefficient is pi by 2. That will be capital. So here coefficient of x square is pi by 2. So nearby numerical coefficient, that is numeral. So that numeral is the coefficient of x square. And here root 2x minus 1. So here, can you observe any x square term here? There is no x square term. Only x term is there, that is root 2x, and then minus 1 is there, a constant. Here there is no x square term. So we cannot say that there is no x square term, so that is no coefficient. If it is x square, then we can say, so what is the coefficient? 0. Coefficient of x square is 0 because there is no x square term. So this is the way to answer this question. And in question number 3, they are asking, give one example each of binomial of degree 35 and a monomial of degree 100. For example, if you write the binomial of degree 35. So binomial means what? A polynomial having 2 terms, but the degree should be 35. So that we have to notice. So degree should be 35 and it is of 2 terms. So x power 35 plus 1. X power 35 plus 1. So it is binomial with variable x and whose exponent is 35, that is the highest power. So it is a binomial of degree 35. And monomial, they are asking example, monomial of degree 100. So monomial means what? Only one term. That should be only one term. And the degree also they have given, that that should be 100. So you can take any variable y with 100, y power 100. If you write y power 100, it is only one term is there. So it is a monomial whose degree is 100. So these are the examples you can take. This is not only the answer. You can write any variable, but you have to maintain that the given condition, that is degree 35 and degree 100. And also the number of terms. Monomial means only one term, binomial means two terms. So the answer may vary. Okay, children, now we move to fourth one. Fourth sum is write the degree of each of the following polynomials. So degree means what? The highest power. So in the first option, fourth one, the first option, 5x cube plus 4x square plus 7x. So here we have to note the degree. So variable is x and the highest power is b. So degree is b. They are asking the degree. The degree is highest power of the given polynomial. So here 3 is the degree. And option 2, the polynomial is 4 minus y square. So here the variable is y. The highest power of the variable y is 2. So the degree is 2. And then coming to option 3. P minus root 7. So here the variable is p. So the variable whose exponent is 1. So it is degree 1. It is of degree 1. And coming to option 4, it is given only 3, the number 3. Can you say the degree of this 3? I already explained that it is a constant polynomial. The constant polynomial degree is, can you say the answer? Already I given a statement. The degree of a non-zero constant polynomial is what? 0. Because you can write this as b into x power 0. So you can put any variable. For example, 3 into y power 0. So any variable you can put, but that exponent should be 0. So you can write 3 as b into x power 0 or 3 into y power 0. So you can have a degree, that is the exponent of the variable 1 is 0. So you can say the degree of the option fourth one is what? 0. Degree is 0. So the by the statement itself we can say the degree of a non-zero constant polynomial is 0. And now coming to question number 5, classify the following. The options are there, 7 options are there. We have to classify this as linear, quadratic or cubic polynomials. So you have to observe all the polynomials given here, and you have to classify whichever comes under linear or quadratic or cubic. So these 3 you have to classify. So what is linear and quadratic and that is cubic? It's based on the degree you have to classify. So degree means highest power. So first of all, in each polynomial, for example, you take x square plus x, the variable is x, and the highest degree of the variable is 2. Therefore, it is what polynomial? Correct. That is quadratic polynomial. It is quadratic polynomial. And here the variable is x, and the highest power of the variable x is 3. So therefore it is cubic polynomial. Just to observe what variable given and what is the highest power of the variable, that is the degree. So the degree is 3. So degree 3 means it is cubic polynomial. And this one. So what variable we have given? Y. And what is the highest power? 2. So that is the degree of this polynomial is 2. Therefore it is quadratic. Very easy one. Just observation. Keen observation. 1 plus x. Here the variable is x. And the highest power of the variable x is 1. Therefore it is degree 1. So linear polynomial. If the degree of a polynomial is 1, it is called linear. If the degree is 2, then it is quadratic. The degree is 3, then it is cubic. And now comes to the next option 3t. Here the variable is t. So what is the degree? 1. Because the highest power is 1. If it is not that, it is understood that it is 1. So it is linear. And this is r square, only the variable r with the exponent 2. No other terms are there. Even though r is a variable and whose exponent is 2, that is degree 2, that is called quadratic polynomial. And the last option is 7x cubed. Here the variable is x and the exponent is 3, that is the degree, which is the highest power. So degree is 3, so it is of cubic polynomial. So now we have finished exercise 2.1, and the next class we will see the zeros of your polynomial in the next exercise. Thank you.